Good morning. For those that don't know me, my name is Christopher Williams, and I currently work as an occupational hygiene specialist for Rio Tinto. I actually come from an occupational therapy background and have seen the impacts and worked with people struggling with conditions associated with occupational exposures. As a result of this, I am passionate about the preservation of worker health and believe occupational hygienists play a key role in not only giving voice to these issues, but also driving the necessary change to prevent people suffering from long-term occupational illnesses. Despite my absence today, I am truly honoured to have both my work and that of countless others that led work captured in this paper recognised. So, before I begin, I wanted to express my gratitude to 3M and the Australian Institute of Occupational Hygiene for the opportunity to present my paper entitled Risk Identification and Strategic Control Implementation, a multidisciplinary approach and the role of the occupational hygiene professional. Consider this. The Sydney Opera House was designed by architect Jorn Utzon. Jorn's design for the Opera House was selected from 233 entries. Now, realising this dream took over 14 years, with the construction of the Sydney Opera House occurring in 3 stages from 1959 to 1973. It also cost $102 million, which was close to 15 times more than the original cost estimate. More importantly though, and perhaps the point of this analogy, was the people and expertise involved. In addition to Jorn Utzon, who ended up resigning in protest in 1966, construction involved 4 other architects, 55 engineers, 10,000 construction workers, and countless others. As elegantly stated on the Opera House's official website, it was an extraordinary collective act of dreaming in public, a work of art built for the performances of work of art, and brought to life by people who believe in the power of imagination. Realising the dream took us all, visionaries and pragmatists, architects, engineers, artists, and most fundamentally, the people of Australia. Now, admittedly, the Sydney Opera House is a much grander project than what I plan to talk about today. Despite this, the underlying themes are similar. A great number of projects require the input and expertise of many to ensure a holistic outcome that lasts the test of time. Additionally, it is important that those that are involved know their role as well as their limitations, and, when necessary, aren't too proud to partner with others to realise a common goal. What I plan to talk to you about today revolves around these same themes and aims to explore 3 key points. 1. The benefits of a multidisciplinary approach. 2. The role, responsibility and limitations of today's occupational hygienist in the pursuit of the preservation of worker health. And 3. The importance of a holistic risk management approach. Occupational health is jointly defined by the World Health and International Labour Organisations as the promotion and maintenance of the highest degree of physical, mental and social well-being of workers in all occupations. Given the scope of this, it's not surprising that these same bodies jointly recognise the importance of a multidisciplinary approach in achieving this aim. In fact, the World Health Organisation calls out several disciplines, including occupational hygiene, as key contributors to this goal. When we consider occupational hygiene and what is expected of our discipline in terms of our contribution to this goal, it can be broken down into 3 separate steps, including measuring worker exposure, assessing worker risk, and providing technical advice on control strategies. I doubt there is any argument that occupational hygienists have a key role to play in the pursuit of health preservation within the workforce. Despite this, in many instances, and in my own experience, the expectation is that we are a one-stop shop and can do all of this effectively on our own. In reality, to do this effectively, I propose that occupational hygienists must assess each scenario on its own merit, and where necessary, realise the potential benefits of partnering with other disciplines and subject matter experts to characterise exposures and identify and implement controls that are both effective and sustainable. The purpose of this talk is to recognise the role of today's occupational hygienist. At the same time, I hope to explore the need for a holistic approach to risk management and outline some of the many advantages of partnering with other disciplines to identify exposures and deliver effective, targeted, and sustainable controls. To explore this concept, I have drawn on my experience from working within a multidisciplinary team known as the Dust Mitigation Working Group. To give you some context, this working group was formed in 2019 in response to an observed increase in worker exposure. In this instance, inhalable dust was identified as a potential risk for 3 work groups across multiple mining operations. These included fixed plant maintainers, operators, and laboratory technicians. For those unfamiliar with these roles, they all work within the fixed plant facility, which is the single largest piece of infrastructure you'll find at an iron ore surface mining operation. It comprises of primary and secondary crushers, screening facilities, stacking and reclaiming systems, and loading facilities. In layman's terms, it is responsible for making big rocks smaller. Unsurprisingly, this process has the potential to generate a large volume of dust. These findings indicated that existing controls within fixed plant facilities were insufficient and/or ineffective. The reason for this generally fell into 3 distinct categories. Effective engineering controls were either absent, as they were not considered at the time of construction, degraded due to inadequate maintenance strategies, or not fit for purpose due to historical changes to operating conditions with insufficient consideration of the impact on the efficacy of existing controls. Regardless, the result was an increase in potential for workers to be exposed above the occupational exposure limit. In response to the potential risk to worker health, it was recognised that a multidisciplinary approach was necessary to identify, prioritise, and deliver effective controls over a sustained period. As a result, the Dust Mitigation Working Group, comprising of an operational manager overseeing engineers, capital project teams, and environment and occupational hygiene specialists, was established. As you can see from the team structure displayed on the slide, the working group sits between the senior management team, otherwise known as the Dust Steerco, and operationally led dust committees. The intent of this structure was threefold. 1. Operations held monthly dust committee meetings in which they reviewed operational performance against dust metrics, investigated operationally led dust control opportunities. 2. The Dust Mitigation Working Group, working in parallel to operations, examined dust management across all operations and utilised various data sources to prioritise and deliver targeted and sustainable engineering controls across multiple operations. And 3, the senior management team provided oversight and, where required, endorsement for future works. Sitting off to the side was the communications team, which were used to keep the business and operational workers informed of the work that was being completed. The primary aim of the Dust Mitigation Working Group was to reduce dust emissions via the implementation of targeted, effective, and sustainable controls. To explore the benefits of partnering with other disciplines, my paper focused on 3 key phases of the dust mitigation project, which I believe align well with the foundational aspects of risk management. These included hazard identification, targeted, fit-for-purpose and sustainable control implementation, and control effectiveness and long-term management. For each of these stages, I have drawn on one specific example of work that was completed with a focus on how this work benefited from the involvement of multiple disciplines. For hazard identification, I will explore the role of the video exposure monitoring in identifying hazards and the benefits of the occupational hygiene and engineer partnership to identify exposure sources. For control implementation, I'll discuss the benefits of engaging subject matter experts to inspect and evaluate controls and propose fit-for-purpose solutions. And for control effectiveness and management, I will talk to the benefits of a collaborative approach in designing a standardised evaluation tool, the aim of which was to assist with the assessment and long-term management of key dust controls. The first phase of this work was hazard identification, which involved defining exposure sources to direct control implementation. For those unfamiliar with the processing plant, the picture on the right should give you some idea of scale. These facilities are spread over large areas and linked by an extensive conveyor system. As a result, unlike other surface mining work groups, the work conducted by fixed plant workers is highly dynamic, with workers moving between areas with no pattern or frequency. Whilst we understood from personal exposure monitoring that those working in this area were overexposed, it was not uncommon for the occupational hygienist to have a limited understanding of the primary cause or causes of observed exposures. This is not to say that some inferences can't be drawn from the data collected, and this should be the initial focus of the occupational hygienist. However, in a facility of this scale, more targeted and sophisticated monitoring was necessary to aid in the identification of exposure sources. In this instance, video exposure monitoring was determined to be the most suitable method to further define the risk within this work area. This technique relies on the pairing of real-time monitoring and video footage, which was collected by the occupational hygienists as they walked a set path through the fixed plant. Whilst the occupational hygienist is best placed to collect this data, the successful collection and interpretation of data within fixed plant requires an intimate knowledge of not only the design and layout of these structures, but also how they interact with each other. Not surprisingly, this level of knowledge extended beyond the expertise of the occupational hygienist, and as a result, a multidisciplinary approach involving an engineer who was familiar with fixed plant assets was deemed necessary to ensure success. To address this, a company engineer was engaged to assist with all aspects of the data collection and analysis process. In partnering with the engineer, the following benefits were realised. 1. Data collection routes through the plant were pre-planned by the engineer, ensuring they captured key dust sources and existing controls. 2. Data interpretation was undertaken with involvement of the engineer, who was better positioned to identify likely sources when elevated dust levels were observed. And 3. Identified exposure sources were prioritised and the recommendations provided were done with consideration of emission levels, practicality and cost. As shown in the graph pictured, video exposure monitoring allowed spikes in real-time monitoring data to be linked to specific areas. With further analysis and input from the engineer, these were then linked to likely exposure sources, which could be the focus of controls. This is but one example, but it clearly demonstrates the benefits of partnering with other disciplines in order to identify and define hazards within the work environment. The second phase focused on control implementation. The aim of this stage was to identify, prioritise and deliver effective controls. For those unfamiliar with the types of dust controls typically found in the fixed plant, they can be broken down into 3 categories. These include dust containment, such as enclosures, skirts, seals and hoods, dust collection systems, and dust suppression systems, such as spray bars. Common examples are pictured on this slide. Whilst video exposure monitoring defined specific exposure sources, it also provided valuable insight into control deficiencies. For example, where high dust emissions were recorded, controls are either entirely absent or, if in place, ineffective. In either case, whilst the company engineer was well placed to comment on structural containment controls, one limitation was their ability to assess the efficacy or suitability of high-level engineering controls, such as dust collection and suppression systems. The reason for this is that these systems are highly specialised and designed with consideration for both the processes and structures they support, as well as the characteristics of the dust generated. Whilst it is within the occupational hygienist and engineer's skill set to assess the performance of existing systems, if this assessment suggests some form of deficiency, diagnosing the cause of this, especially if it is complex in nature, is likely to sit outside their capability. In addition to this, whilst these two disciplines can comment on the absence of engineering controls and outline the potential benefit they may bring to certain areas, They lacked the expertise necessary to provide detail regarding the feasibility and potential costs associated with this recommendation. In order to implement targeted, fit-for-purpose and sustainable controls in a strategic manner, it was first necessary to understand the condition of existing controls, or, in the instance where controls are absent, what control options were even feasible. To assist with this, external consultants who specialised in these systems were commissioned to inspect all existing dust collection and suppression systems. The intent of this work was to evaluate existing control adequacy, diagnose issues, determine the work necessary to address deficiencies, and where required, propose potential control options to address dust emission sources. The engagement of subject matter experts and the resultant data obtained ensured the following benefits were realised. 1. A holistic understanding of the current state of controls, control options available to improve performance and more precise cost estimates. The ability to make informed and strategic decisions in relation to control implementation. This included prioritisation of work that brought existing systems back online quickly, all the way through to long-term budgeting and planning to redesign and implement new fit-for-purpose controls. In much the same way that video exposure monitoring highlighted the strengths and limitations of the occupational hygienist and the benefits that came from the involvement of the engineer, this example demonstrates the need to continually evaluate the skill set of those involved, and where necessary, to acknowledge limitations where they exist. In this instance, the engagement of a team with specialised expertise ensured a robust evaluation of existing engineering controls, and the result was reliable data to guide strategic control implementation. The third and final stage of this work involved control effectiveness and management. The purpose of this phase of works was to ensure sustainable practices were in place to assess and manage the long-term operational effectiveness of controls. Following the successful implementation of effective controls, it was necessary to implement practices that assessed their ongoing effectiveness. For those that aren't familiar with Western Australian legislation, it is a statutory requirement for surface mining operations to appoint a surface ventilation officer. Under the new work health and safety regulations, these will be known as air quality officers. Within RIO, this role is predominantly held by the occupational hygienist and involves the regular inspection and assessment of key dust controls with the aim of ensuring effectiveness and, when necessary, identifying defects which undermine the performance of the control. Should any defects or deficiencies be identified, the expectation is that these be recorded and escalated for rectification. Despite the benefits of this statutory role and these activities, there had never been a standardised process to carry out inspections. As a result, this process was inconsistently applied and lacked engagement with parties who had the expertise to accurately identify and diagnose potential defects. Not surprisingly, this contributed to poor outcomes when trying to address faults. To improve the outcomes associated with these inspections, the occupational hygienist partnered with the engineering and internal maintenance teams to develop an auditing tool. The intent of this work was threefold. 1. Develop a standard ventilation inspection tool to audit existing dust controls common to surface mining operations. 2. Create a process to determine inspection frequencies based on the asset risk. And 3. Develop a live dashboard that captures key findings from ventilation inspections and enables operations to view trends and key metrics resulting from the inspection process. Work is ongoing to create a live dashboard. However, the ventilation inspection and frequency tool have both been standardised and implemented across all operations. Whilst the occupational hygienist drove this project, the involvement of both the engineering and maintenance teams was integral to capturing the full scope of dust controls. Additionally, this process ensured the final tool was user-friendly and provided output that not only supported regulatory requirements, but also facilitated work to address identified defects. This is yet another example of how a multidisciplinary approach can be taken to improve existing practices and in this instance, ensure workers continue to benefit from operational controls. Whilst my paper focused on the dust mitigation working group, it is worth noting that multidisciplinary working groups are becoming more common. A recent example of this is the company response to COVID-19, in which a large multidisciplinary response team was formed to tackle the issues and associated business risks that emerged with this worldwide pandemic. This team continues to manage these risks today, and much like the dust mitigation working group, it has demonstrated the benefits of this approach by delivering practical solutions to complex business risks. To conclude, occupational hygienists have a core role to play in both the identification and reduction of exposures within the workforce. If my involvement in the dust mitigation working group has taught me anything, it is that occupational hygienists and their employees must be aware of their limitations and, where necessary, recognise the benefits of partnering with other expertise to ensure the best possible outcomes. Whilst our discipline may be best suited to lead certain elements, there are a few instances in which our expertise doesn't benefit from the input of others. In contrast to this, we must also recognise those times where skill sets are better suited to the task, and in these instances, partner with them to ensure a holistic approach. Whichever way you choose to cut this, the benefits of a multidisciplinary approach in relation to risk management are clear. Lastly, in order to effectively manage risk within the work environment, we must ensure a holistic approach. This approach ensures the right expertise are involved and the data collected is sufficient to guide the necessary response. Additionally, it is important that this approach looks beyond the identification and implementation stages and includes sustainable practices that continue to assess and manage the ongoing effectiveness of controls. I'd like to thank all of you for attending today, and should you have any questions, as I'm unable to be there, please feel free to send me an email on the below email address. I hope you enjoy the rest of the conference, and thanks again.